This is a tutorial on how to use the two-way ANOVA or ANOVA two-factor in Excel. A two-way ANOVA or analysis of variance is used when you have two independent variables or the factors, each with two or more levels, and you want to investigate the effects of both variables, including potential interactions between them on a single dependent variable. This problem is an example of two-way ANOVA. So here is the problem. A civil engineer wants to examine the effects of cement type and curing method on the 28-day compressive strength of concrete. There are three types of cement and two types of curing methods. Each combination is tested with two specimens or replicates or trials. So we have factor A, the cement type, and we have three types of cement: type 1, type 2, and type 3. The factor B is the curing method, and it has two levels or two types: water cured and air cured. This is the data of the compressive strength of the concrete in megapascal. So we have here type 1, type 2, and type 3. So each type of cement was cured using different method, the water cured and air cured. And each combination has two samples. So we have sample 1 and sample 2. So that is the replicates or the specimen. For the problem statement, at the 0.05 significance level, so that is the alpha, number 1, does the type of cement significantly affect the 28-day compressive strength of concrete? Number 2, does the curing method significantly affect the 28-day compressive strength of concrete? And for the third question, is there a significant interaction between cement type and curing method on the 28-day compressive strength of concrete? So based on the problem, our IV, or the independent variable, so we have two independent variables, the cement type and the curing method. So for the cement type, there are three levels. For the curing method, we have two levels. Our dependent variable is the compressive strength of the concrete. So based from these factors, we have two factors, each has two or more levels and single dependent variable. So this is a problem where we can use the two-way ANOVA or the ANOVA two-factor. So we can perform the two-way ANOVA here in Excel using its data analysis toolpack. But before that, let's write the hypothesis first. So we have three problem statements, meaning we have three sets of hypotheses. So one null hypothesis and one alternative hypothesis for the question 1, then another null and alternative hypothesis for question 2, and same with question 3. So we write first the null hypothesis and alternative for question 1. So HO, that is the null hypothesis. So don't forget, null hypothesis, there is no significant effect. So the question here is, does the type of cement significantly affect the compressive strength? So the null here will be, there is no significant effect of the cement type on the 28-day compressive strength of concrete. So meaning, the mean compressive strength of type 1 is equal to the mean compressive strength of type 2 and also equal to the mean compressive strength of type 3 because there is no effect or there is no difference among the three types. So for the alternative, there is a significant effect. So there is a significant effect of cement type on 28-day compressive strength of concrete. So there is at least one or two that is different among the three types. For the number 2 question, so there is another set here of the null hypothesis and alternative hypothesis. So let's read the question number 2 again. Does the curing method significantly affect the 28-day compressive strength of concrete? So the independent variable now here will be the curing method. So null hypothesis will be there is no significant effect of curing method on the 28-day compressive strength of concrete. So meaning the compressive strength of the water cured is equal to the compressive strength of air cured because there is no difference. And for the alternative hypothesis, so we will negate the null, so that is there is a significant effect of curing method on the 28-day compressive strength of concrete. So for the third question, we have again the null hypothesis. Based from the question, is there a significant interaction? So we want to know if there is interaction between the two independent variables. Is type 1 better with air cured, or is it better with water cured, or type 2 better with air cured or better with water cured? So that is what we mean by interaction. So for the null, there is no significant interaction between cement type and curing method on the 28-day compressive strength of concrete. So meaning either combination is the same because there is no significant. And for the alternative, so we will negate the null, so that would be there is significant interaction. So there is a significant interaction between cement type and curing method on the 28-day compressive strength of concrete. So these are the three questions that we need to answer using hypothesis testing here in Excel. So let's perform the two-way ANOVA. But before that, let's organize the table or the data that we need in the two-way ANOVA test. The data should be arranged in this manner. Water cured, then we have air cured, then each curing method uses the three types of the cement. So for type 1, type 2, and type 3. So each combination has two samples. So let's take a look at the data. So for the water cured type 1, we have here sample 1 and sample 2. So we will copy this data here. So that is for the this is for the sample 1 and this one is for the sample 2. So that is for type 1 water cured. Then next, for type 1 air cured. So type 1 air cured is this one. So we will copy the two samples. Then we do the same for the next two types. So for type 2 water cured, there should be two samples also. So for type 2 water cured, we have 34, 33.5. For the air cured, we have 30.5 and 31. For type 3 water cured, we have 36.2 and 35.8. For type 3 air cured, we have 32 and 31.5. So this is how we arrange the data. Next, after we have organized the data in this manner, we can perform the ANOVA two-way test. So let's go to data, then data analysis. So here we have ANOVA single factor, so we do not need that. ANOVA two-factor with replication, then ANOVA two-factor without replication. So we have two choices. So ANOVA two-factor with replication, we will use that if we have more than one samples for each combination. For this one, the ANOVA two-factor without replication, if we only have one trial or one specimen or one replicate for each combination. So our sample problem is with replication because we have two samples for each combination. So we will click on that. So for the input range, we need to highlight all of this, so including the labels. Then rows per sample. So rows meaning how many sample for each type. So we have two samples because we have sample 1 and sample 2. So we will input here 2. For the alpha, so the given in the problem is 0.05, so we do not need that. Then for the output range, so we can choose any blank cell. Then click on OK. Here is the result for the ANOVA two-factor with replications. So we have here different table. We have the summary for type 1, summary for type 2, summary for type 3, and the total. And of course, we have the ANOVA table. So for the type 1, so we can see here the total count. So we have 2 samples for water cured, then 2 samples for air cured, a total of 4. For the sum, so that is the total of the compressive strength for water cured, also for air cured. The average, that is the sum divided by the count. So for the variance that is computed already, that is the sample variance for each curing method. So same with type 2 and type 3. So we can use these computations or result in interpreting our results. Then we have the total. And the most important, we have here the ANOVA table. So same from the one-way ANOVA, we have the source of variation, but here we have sample, columns, interaction, and within. Then we have the SS, that is the sum of squares. Then we have the degrees of freedom. MS, the mean square. F, that is the F value from the F distribution. We have the P value or the probability. Then the critical value based on the alpha. So how to use this table to decide whether we reject or do not reject the null hypothesis in this problem. So for the question number 1, our null hypothesis is there is no significant effect of cement type on the 28-day compressive strength of concrete. So we are referring to the independent variable cement type. So in our data, our cement type is type 1, type 2, and type 3. So here, we will check this in the ANOVA table with the sample data. So meaning this sample data is for the cement type. For the columns, that is for the data or the factor that we have written in column, which is the curing method. So the column will be for the curing method. And for the interaction, that is our third question that we want to answer. If there is significant interaction between the two factors. So we have discussed already on the one-way ANOVA, how to use the ANOVA table in deciding. So for our question number 1, so here is our decision. So for question number 1, so based on our ANOVA table, the F value for the cement type is 53.08, whereas the F critical is 5.14. So the F value is greater than the F critical, meaning we reject the HO. So the same, if we want to use the p-value, the p-value is 0.00015, which is less than the alpha 0.05, so we also reject the HO. So that is our decision for number 1. For question number 2, so we go to the column, which is curing method. So the F critical is 282. So the F value is 282.5, which is greater than the F critical. So meaning, we again reject the HO. Also, using the p-value for the columns, that is 2.83 times 10 raised to negative 6, which is less than the alpha 0.05, so we also reject the HO. So the same decision. For the third question, so we go to the interaction. So the F value is 5.18, while the F critical is 5.14. So F value is greater than the F critical, meaning we also reject the HO. So again, if you want to use the p-value, it is 0.049, which is a little bit less than the alpha 0.05. So using this result, we reject the HO. So these are our decisions for this problem. So for the conclusion, so we will conclude here. Because we have rejected the HO for the question number 1, this is in favor of the alternative. So we can just copy this one. So we have rejected the null hypothesis in favor of the alternative hypothesis. So the same with question number 2. We have rejected the HO, so that is in favor of the alternative hypothesis. So we will just copy that. There is also a significant effect of the curing method. And for the third question, so we again rejected the HO. So the conclusion will be there is also significant interaction between the two independent variables, which are cement type and curing methods, on the 28-day compressive strength of the concrete. So this is how we perform a two-way ANOVA in Excel. So because we have concluded that there is significant effect of the cement and also for the curing method on the compressive strength and the interaction, we can now perform a post hoc test to know where is the significant difference. Is it in the type 1, type 2, or type 3, or which between the two curing methods? So those post hoc tests was discussed in the one-way ANOVA video.